Okay, today I'm gonna presenting myself attempting to solve a problem that is provided. So we have a tank here and a pump and a 2 meter of pipe with the diameter 0.07 meters, and also we have the relationship between the head pump and the flow rate is 20 minus 2000 Q square. This is a very important detail that we're going to use to solve the problem later. So we are asked to find the flow rate and show that the flow is fully turbulent, and also find the power if the coefficient is 70%. This means eta equal 0.7, and we are asked to find W shaft. Okay, so first thing first, so for A, find Q meter cube per second. So let's recall the head loss equation. So we have, let's call this one. Sorry. So let's call this 1, and 2 is right at the axis. So we have the head loss equation, P1 over gamma plus V1 squared 2G plus Z1 plus head pump equal P2 over gamma plus V2 squared over 2G plus Z2 plus head loss. So we are gonna cancel some term out. So we have P1 and P2 are open atmosphere, so we can cancel them out. And also V1 is 0 and Z2 is 0. So we end up with head pump equals V2 squared over 2G plus head loss plus Z1, which is 6 meters. So let's call the average velocity flow through the pipe let's call V is the average velocity flow through the pipe. So we have head pump equals V squared over 2G plus head loss plus, no, this should be minus 6. So we call this equation 1. So for the head loss, we have head loss major plus head loss minor. For major, we have head loss equal F friction factor times L over D times V squared over 2G. So we have L and D, but we don't have F and V. So just plug in V and D for now. So we have F times 2 meters over 0.07 meters times V squared over 2G. So this is gonna be F times 28.57 time V squared over 2G. Okay, so we have head loss major. We need to find the minor loss. HL minor equal KL V squared over 2G. So for the short H entrant, we have the loss coefficient of 0.5. So we have minus loss coefficient H entrant KL equals 0.5. In figure 0.22 in textbook. So that loss minor equal 0.5 V squared over 2G. Okay. So we have head loss total equals 28.57 F V squared over 2G plus 0.5 V squared over 2G. Let's just factor out this term, V squared over 2G. We have 28.57 plus F plus 0.5 times V squared over 2G. Okay, so let's call this equation number 2. So from equation number 1 and 2, we have HB equal V squared over 2G plus this whole term right here, 28.57 F plus 0.5 times V squared over 2G plus minus 6, right? And also we have the relationship right here. So let's just use that one. The relationship between flow rate and head pump. HP equal 20 minus 2000 Q squared. So we have 20 minus 2000 q squared equal v squared over 2g plus 28.57 f plus 0.5 v squared over 2g minus 6. All right. We also have that flow rate equal area times velocity, which is equal pi d squared over 4 times v equal pi over 4 times 0.07 meter squared times v. Q equals 4. So this is gonna be 0.00385 v. Let's plug it back in right here. We have 20 minus 2000 times 0.00385 v square equals v square over 2g plus 28.57 f plus 0.5 v square over 2g minus 6. Alright, let's do some algebra with this. So we bring the v term to one side and the other term to the other side. So we end up with 2,285 v square plus v square over 2g plus 28.57 f plus 0.5 v square over 2g minus 6. Oh, hold on. Let's bring the 6 to this side. We have 26 right here. Okay. So 26 equals 2000 times 0.0385 square. Wait. I need one more zero. So it's gonna be 0.029645 v square plus this term. Wait, we can factor out the v square over 2g term right here. So it's gonna be v square over 2g 1 plus 28.57 f plus 0.5, right? Okay, so we have 26 equals 29645 v square plus v square over 2g. So this is gonna be 1.5, 28.57 f equal. Let's just distribute this term back in. Let's see what we end up with. per second. So so 1.5 divided by 2 times 9.8 meter per second, we have 0.0765 v squared plus we have, wait, I forgot the v squared term right here. 28.57 divided by 2 times 9.8, we have 1.4576 f v squared. So to split this equals 645 plus 0.0765, 0.106145 v squared plus 1.4576 f v squared. Let's factor out v squared. We have 26 equal v squared 0.106145 plus 1.4576 f. So from this point, we can see the relationship between v and f. We have v squared equals 26 divided by the term on the bottom. So v equals square root of the whole thing. Okay. So right now we have to find friction factor F in order to find V, and from V we go back here, we can find Q. So we have Reynolds number, RE equal D mu, which is equal 1000 kilogram per cubic meter times V times 0.07 meters divided by 1.12 times 10 to the minus 3. This is in Newton second meter cube. No, meter square, I'm sorry. So we have Reynolds number equals 1000 times 0.7 divided by 1.12 times 10 to the negative 3. 62500 V, but we have V right here. Just plug V to get Reynolds number. 6 over 0.106145 plus 1.4576 F. Okay, so the flow is given turbulent, which means we can use Colebrook formula to find the friction factor. I'm gonna just copy from the textbook. Over 3.7 plus 2.51 over Reynolds number times square root of F. So for cast iron pipe, we have the roughness. Is 0.26 millimeters, which equals 0.26 times 10 to the minus 3 meters. So we have 1 over square root of F equals minus 2 log 10 of 0.26 times 10 to the minus 3 meters over 0.07 meters over 3.7 plus 2.51 over Reynolds number right here. 6250 26 over 5 plus 1.4576 F times square root of F. Alright, let's just clean up a little bit. We have this. One point 0.0038 times 10 to the minus 3 plus 2.51 over 6. No. Over square root of 0.106145 plus 1.4576 F. Ooh. What a mess. So just put the whole thing in the calculator and let it run to solve F. So we have F equals 0.028. All right. So with this, we can solve for V right here. Just bring it back. Wait, hold on, I did something wrong. Let me check. Make sure everything is fine. Six. Okay, yeah. So V equals 13.3 meter per second. So let's recall Q equals AV millimeter per second. So we have pi over 4 times 0.07 square times 13.3. So Q is 0.0512 0.0512 cubic meter per second. So B, we are asked to show that the observation of fully turbulent is correct. So bring back Reynolds number up here equals 62,500. V equals 500 times 13.3 meter per second. We have 83.1250. This way above 2000, which means this is turbulent flow. So for C, we have efficient of 70%. So we have the formula W shaft. So W shaft equal rho GQ head pump over eta equals 1000 kilogram per cubic meters times 9.8 meter per second square times our cube 0.0512 meter cube per second time the head pump we have here 20 minus 2000 Q square all over 0.7. So we have W shaft equals 1000 times 9.8 times 0.0512 times 20 minus 2000 times 0.0512 square all over 0.7. We have 10,578 watt, which equals 10.578 kilowatt. I'm not sure this is the right answer, but I try my best to solve the problem professor provided for us. So my name is Trung Nguyen. I'm gonna sign my name right here. And thank you for watching.